Now we have seen the demos how the process running on a system can be viewed both on the Linux and the Windows system, and also the process tree, the hierarchical relationship between different processes. So as I said, the process often have the appropriate privileges. So meaning the operating system grants different privileges to these processes. So some process which actually has to do some system operations may have different privileges than some other process which actually, the example that I gave, a C program written for adding two numbers may not require those kind of privileges. So depending upon what that program is supposed to do and who is actually running that program, this privilege is decided by the operating system. I repeat, what that process or program is supposed to do and who exactly is running that program. So whether the owner of the file itself or the who wrote the program itself is running, there is a concept called as the user, whether they are running or the users are running. So if the user, there are some privileges assigned to that every user who on the system is identified by a number assigned to that. This is called user ID. This number on the Linux system ranges between this 0 to 32,767. And similarly, there is also a concept called the group. Every time you create a user, so that user can be part of some group. Let's say there are 50 users on the system, and then all of them can be grouped into, let's say, 5 groups. So roughly one group might have 7 users, the second group might have 15 users, and so forth. So like this, I can actually group. So that group is also identified by a number. That number is also in the range between 0 to 32,767. So those many number of the unique users or groups can be there on the Linux system. So typically, when a program is run, when a process is run, so the privileges associated with the user who is running that program is applied to that process. So if let's say particular user U1 doesn't have the permission to access a particular resource, so when this program is run, when the process is created, so typically that may not also have access to that particular resource. So like this, the operating system controls who is the user and what is allowed to do. If a particular process is created when the user U1 runs this process P1, whatever is the applicable access controls are there on the user U1 is also applied to the process P1. So like this, the operating system actually controls the access and also what the process can do at the runtime. So that what we wanted to remember, so we don't want one application or one program to tamper with the other application, and one user not tampering, you don't want to tamper with the other users. So if a particular user has got, let's say I create one file and then and that I kept something, a secret thing, and then I don't want others to view that. So if you create one process and it possibly, if it attempts to delete that, then the operating system should not allow that to delete that file. So that is actually decided by this privileges assigned to that process. And although when I create a process, when I run one program, so it should run as a standalone program. Often there are situations where one process may requires access to or this share data with the other process. So process P1, P2, P3 are running same time parallelly on the system, and we want to share some data between process P1 and P2. So the best example might be, let's say I have an charting application. So whatever I type here, a process is running on my computer, and then a similar process is running on your computer. So if I want to send share whatever I type here in my chat box, and it should be sent here. This is an inter-process communication. Although these two processes are running on two different systems, but the same thing can be viewed on the two different processes running on the same computer as well. So what are the ways with which the processes can communicate with each other? So I remember I want to only those two processes which are having some kind of the agreement. Okay, whatever I am sharing, you should be able to access. Whatever you are saying, I should be whatever you are saying, I should be able to access or read or something like that. Whenever those two processes are in some form of the agreement, only then this data should be passed on. So it should not happen that the word processor program, whatever the data or the resources, whatever is there, and that data that generated by the word processor should not go to the a music application. So how do I actually control that? This is done with a well-defined process, how we actually exchange the data. The simplest form of the form with which data can be accessed is, you can write, let's say I have two processes, let's say P1 and then P2, and what I can do is I can create one dummy file or an intermediate file you can call. So if I want P1 and P2 to exchange the data, so what I can do is I can ask P1 to go, and whenever it has something to send to P2, you write this to this file. Let's say this file as, let's call as F1. So P1 is writing something to the file, and I can ask P2 to give access to this file, and then it can actually read the contents from this file. So one is writing, the other one is reading. So assuming the read operation always happens after the something is written by the other process. So this can happen. So this can run smoothly. So the operating system need to facilitate, it need to control this. So something when one is writing, the other one allowing the other process to read, and when the other process is writing this one, when P2 is writing, P1 should not be reading that. So like this, I can create multiple files, and then maybe this is the F1 is for a situation where P1 is writing, P2 is reading, and similarly I can also create another file, let's say F2, where P2 is writing here and P1 might be reading. So like that, I can even establish a bidirectional communication where one process can read and the other process can write. So the second method of inter-process communication, that the exchange of the data between two processes or multiple processes, is through something called the pipes. Pipes is an Unix terminology where one process, there is a kind of the channel that gets established between, direct channel that gets established between the processes. So P1 is there, and then process P2 is there, and then there is a kind of the link. This we call it as the channel or the pipe. Pipes are the second way with which you can actually do the inter-process communication. The best way to understand is to look at the pipe the way they are used in the Linux system. Let's take a look at that again, how pipes are used in the Linux system. Let's go to this directory, documents. Now I've got 4 files in this directory. F1, F2 and E1 and U2. Let me open one terminal. And what I want is, I want to list, if I type ls command, then all the 4 files in this directory are listed. But what I want is, sometimes I may want to filter out or list out only the files which are starting with the letter F. I can use the grep command to do that. Now there is this vertical line is the pipe. So the first is ls command gets executed, and then whatever is the output that ls command provides, that is given as input to the second command, which is a grep, and then then you should see only these two files, F1 and F2, these two getting listed. So this is called piping. You can have any number of the such pipes. So the evaluation starts from the very first command and then subsequently goes one step further, from one command to the next command to the third command and so forth. Okay, we looked at the demo of how the pipes are used on the Linux system, and the third method of doing the inter-process communication between the two or more processes is something called the sockets. So in the networking course and all, you might have seen sockets are the way to communicate between the processes, particularly the example that I gave, the charting application. So one process, one charting application, one process is running on my computer, and the PL process or the application is running on someone else's computer. And whatever I take here should go there, and whatever the peer types, then that content should come to a computer. So these two processes are exchanging the data. The way that is done is to modern system is to the socket interface. That is the way. So I'll not go into the details of different kinds of the sockets and how they are opened in this course. So assuming that you have seen how to write programs with the sockets in the networking course, yes, sockets are the third way of doing the inter-process communication. And that is about the process. What are the inbuilt security mechanisms are there in the process? The second kind of the facility that an operating system provides is called as the file system. File system, in fact, most of the operating system today provide have got some kind of the file system. So file system is simply an abstraction that an operating system provides to the users to store something in the non-volatile memory. So every time I want to store some content, I am going to create one file and then write something to that file, and then that gets stored into the non-volatile memory, which is might be disk in most of the systems. So, so the file, there are a bunch of operations that you can do. One is you can create the file. The second one is you can write content to the file, you can read it, and sometimes you can also execute it, and all these operations you can do. So the file system abstraction that the operating system provides, it actually provides all these kind of the operations to be done on those files. So these files, for the ease of management, the operating system also provides a way to organize those files, particularly in the form of a directory. So you create a directory, and then inside that directory you can actually have subdirectories or files and so forth. So that is a way to organize. This is just like the process tree. So the files are also organized in a hierarchical fashion. So now, as I said, we don't want the arbitrary users and arbitrary processes invoked or created by the arbitrary users to access these files. We need to have some kind of the mechanism through which we control who is going to do what on this particular file. Particularly the questions like who should access which set of the files, who should execute what kind of the applications and the programs on the system, and basically by virtue of that, by controlling this, who should read what, who should write what on which file, and who should execute which file. We want to prevent the file content from one file to be accessed by some unauthorized users or the unauthorized process. So this operating system also provides the file system abstraction that we discussed, also come with some kind of the mechanism, or you can call it as the access control mechanism to restrict this from happening. So each file, as I said, has got certain access restrictions. So that access restrictions are also called as the privileges on the system, and some users have got the special privileges on the system. These are called as the administrative users, or on the Linux terminology, the Unix terminology, these are called as the root users. So root user has got the complete control. In some sense, he actually owns all the files, he controls all the process on the system. So other than the root, if there is let's say the other user, call it as U1. So the user U1 might have got some restricted privileges. So kind of what he might be able to see, depending upon whether he is part of the group 1, 2, 3 or not part of any of the group. He is actually allowed to do some operations. So he might own some files, he might have got access to certain files. So typically in a multi-user environment, let's say he wants to install something, he should be able to do that. But the other users, normal users, should not be able to install the some applications on the system. This is actually privilege. They may not be able to read some of the files or write in some of the files. So the operating system actually controls that by providing such kind of the access restrictions.
So let's take a look at how file permissions can be viewed on the Linux system. Let me open this directory. Currently there are no files in this directory. So let me open a terminal, and then maybe we can create one file. So let's say I want to create a file by name F1. This is the command. So a file is actually created here, and let put some content here. So let's say I'll write hello here, and then save this, close this, and come back to the terminal. So the way to view the various permissions within the which are assigned to the file, one is to type ls -l command, and it will show what are the permissions that are assigned. So for this file name F1, the first bit here it indicates whether this is a directory or not. If it is a directory, then there is a letter D that is shown here, and the remaining 3 bits are the permissions given to the owner of this file F1, and the next 3 bits is the are the permissions given to the group to which the owner of this file belongs to, and the last 3 bits indicate the permissions given to the other users. So we can easily see that the owner has got the read and write, but no execute permission here, since it's a text file. And the group also has got the read write permission but not execute, but the others have got only the read permission but not write and the execute permission. So this permission can be changed using the command called chmod. chmod, and then I can give whatever permissions that I want to give. Maybe let's say I want to add execute permission to all the users. I say plus and then X, the file is F1. So the change is done. So let's go back and execute and see whether everybody has got the execute permission. So here you can see that owner has got the execute permission, and also the group members can also execute this file, but the others can also execute this file who are not the who are not part of the group or also do not own this file. So similarly, if I want to remove the permissions that are a particular type of permission, I can use the -1 and then -x, the execute the permission that was given to this file should be now revoked. So we are back to the English. We can see that now read, write, and execute. There are no execute permission to any of the members. So this chmod command can also be is not necessarily using this plus and minus thing, but also you can use treating these 3 digits as as binary number, and then you can convert that into decimal and then use it. So for example, this read, write, and execute, these 3 together, if I write 1 in this position, that sets the read permission, and then if I write 1 into the W, then that is the giving you the write permission. If I write 1 into this position, then that is the execute permission. So together, if I write 1 here, then that indicates that the owner has got the all the permissions, read, write, and execute permissions. Similarly, the next 3 digits can also be mapped. So for example, if I want to give only the read permission to the other group members, I can set 1 here, and these 2 can be 0. Then the binary number, if I convert into decimal, that becomes the 4. And similarly, whatever the permissions I want to give. So for example, I don't want to give any access, either read, write, or execute permission to the others, then that can be, all these can be reset. Then the decimal number equivalent to that is going to be 0. So what I'll do is I'll use chmod command now, and then I hit 7 here. That is the read, write, and execute permission to the owner. And then I want to give only the read permission to the group members, but not anything else to the none of them read, write, execute permission to the other members. Then if I type this and hit enter, so appropriate changes should be done. So what do we want? Owner should have all the 3 permissions, and the group members should have only the read permission, and then the others should not have any permission. So you can see this read, write, and execute permission is given to the owner, and only the read permission to the group members, but no permission to the other members. So like this, you can actually change the file permissions and restricts who can do what on this particular file.
So the Unix and the Linux variants of the operating systems have got a thing with them. They treat everything as a file on the system, including the various devices that are connected to the system. The printer is a file. The other, well, even the sockets, the interprocess communication that is happening between 2 systems are also treated as a file. So whenever you have some data to be transferred to any of the device, other process, it's all treated as a file, and then it is written and read. And they saw the permissions are read, write, and execute permissions. So if you give write permissions to other users, so then they have got the control. If, let's say I own a particular file, and then I give, you are not part of the group to which I belong, then if you have got the right permission, then you can actually come and overwrite whatever I have stored in my file, or you can also delete the file itself, the file that I have stored. So in some situations, a problem, although I may want to give write access to you, you can write content to your file, but I don't want you to either accidentally or deliberately delete that file from the system. So in that situation, the Linux provides or the Unix provides a special kind of the permission called as the sticky bit. What sticky bit is, although it has got the right permission, this sticky bit is usually set on the, and then if I give right permission to all the files in that particular folder, you can write content to that file, but you cannot actually delete those files. So if I apply this sticky bit on that particular folder, in a particular directory, I have got two files, F1 and F2. I'll set, let's say, the directory name itself is maybe D1. I set this sticky bit on the D1. And if I set the sticky bit on the D1, then both F1 and F2 may have right access to others who are not the owner and the group, but they cannot actually delete the files F1 and F2. This becomes sometimes useful, particularly for system files and other situations. And we can set and unset the sticky bit on the particular directory. Let's take a look with a demo how the sticky bit can be set and unset.
Got documents on this desktop. Let me open a terminal, and I want to see what are the permissions that are applied to the documents directory. So you can see documents is a directory, so that is why the letter D, you can see D indicates the directory. Then the owner has got the permission of read, write and execute, and the group members have also got the permissions of read, write and execute, but the others can only do the read and the execute operations on the files of this folder, on the various files of this folder documents. Now I can go and change and set the sticky bit on this particular folder documents. The way to do it is to again use the chmod command and then plus D, and to which directory you want to apply this documents. So hit the enter, the change is done, and now you can actually check that